Assalamu alaikum wa rahmatullahi wa barakatuh, students. We are going to start chapter 4. This is Laplace transform. Laplace transform is an integral. Let f be the function defined for t greater than 0, then the integral this into Laplace of f of t, 0 to infinity, e raised to minus st f of t dt is said to be the Laplace transform of f, provided the integral converges. As we can clearly see that it's an improper integral, and we know from our knowledge in calculus that improper integrals can converge or diverge. For some functions, it will converge and we can find the Laplace transform. For some functions, it will diverge and we cannot find the Laplace transform. But in this course, luckily, the good news is we do not need to worry about the convergence or divergence of this integral because we are only going to use a formula sheet to calculate the Laplace transform. But just to create the connection, I'll just solve this one simple integral, one example only. Let's say if we have to find Laplace of 1. So if we are, so this function f of t is 1. Okay. In this case, our f of t is 1. So we replace f of t equals 1 here and over here. Okay. Over here. E raised by minus st, 0 to infinity, integral dt, the rest of the things, all of them, they stay the same, whatever our function is. So we just replace the function, multiply with e raised by minus st, and then integrate and calculate the limit, and we get the answer. So when we multiply it with 1, so it becomes e raised by minus st. Integral is e raised by minus st over minus s with respect to t. Because it's an improper integral, we must use limit to solve it. Standard calculus. So we use b for infinity, and then b goes to infinity, and then we put b and 0 into the function. Calculus for fundamental theorem of calculus. This part of the problem, this one over here, this one over here, it has e power minus sb, and b is going infinity. If s is positive, then it can go down like this. So limit b goes to infinity 1 over e power sb, and when b goes to infinity, this will go to 0. But s has to be positive for this limit to go 0. So we say that if s is positive, then if s is positive, this part goes to 0, this part gives plus 1 over s. So we say if s is positive, then Laplace of 1 is 1 over s. What we have done is we put 1 here and here and then solve the integral, but we need this extra condition to solve the integral. So Laplace of 1 is equal to 1 over s if s is greater than 0. Similarly, we can do the same procedure. Let's say if our function is cos of 2t, then e raised by minus st cos 2t. So that's our function f of t. E raised by minus st is always the same. So that's the same. 0 to infinity dt is same. Now I'm not going to solve this integral. As I said, we are not going to do the details of this integral solution in this course, but table tells me that the answer is s over s square plus 4. Right. So Laplace of the function cos of 2t is s over s square plus 4. Note that t and s, there are two variables, so to say, in the inside the integral. We are integrating over t. That's why we are getting s in the answer, and that will always be the case. We start with a function of t, and we get a function of s in the answer. Let's look at the table then. Here is our table. I think this formula needs to be changed, although I'm not going to do inverses right now, but I would rather change the formula. So I'll go. Actually, I did record all these sorry, lectures before, but there was some problem with the mic and some missing audio in many places, and that's why I'm using the same lectures and recording audio again actually. That's why they are written already. Right. So here is the corrected formula, but we are only going to use this part of the table where we have Laplace. Right, Laplace of 1 is 1 over s, as we have seen above here. We usually don't put this condition s greater than 0 or any other conditions along with the formulas. They are understood that there are some conditions. They exist under certain condition, like this one, s greater than 0 over here. But for now, we are going to ignore that. Laplace of t power n is n factorial over Sn plus 1. N is going to change, of course. For n equals 3, we will get 3 factorial over s power 3 plus 1 and so on. E power at, a is the one going to change here. S will be fixed. Same is for sine kt. So k, we will replace k here. Cos kt, k. But this s will not change. Is exactly the same. Whatever k is, we always put this s here. Hyperbolics, again, k will change, but with a minus this time. And cos hyperbolic is again minus, but with an s at the top. These are two very important results. Not exactly the formulas, but very good results. Right. Laplace of 4. Laplace of 4, we know that Laplace of 1 is 1 over s. We take 4 out using this formula here, L16. So if b is a constant, b can go outside the Laplace, and we can take Laplace of the function. Our function is 1 constant function here. 4 times 1 over s, that gives 4 over s. It's very simple. Next is Laplace of e power 6t. Formula is Laplace of e power at is 1 over s minus a. So a is 6 in our case. That becomes 1 over s minus 6. Next is Laplace of sine 2t. So formula is sine of kt equals k over s square plus k square. And k is 2 in our case. So we replace k here at the top. And we replace k here. So k will be replaced here and here. S will not change. So that will become, all right, pause the video and give it a try. So it becomes 2 over s square plus 2 square. S will not change, only k will change, which is equal to 2 over s square plus 4. Let's see one more example from our second formula that involves factorial. This one here. Laplace of t power n equals n factorial over Sn plus 1. So if we have Laplace of t cube, 3 factorial over. So n is 3. Our formula is t power n factorial over Sn plus 1. N factorial, as I hope you know already, n into n minus 1 up to 3 to 1. We just multiply all the numbers starting with the number. This one is like, for example, 4 factorial is 4, multiply 3, multiply 2, multiply 1. So that makes 24. Laplace of t cube would be 3 factorial, that's n factorial here, and divided by s power n plus 1, so that is 3 plus 1. So 6, 3 factorial is 3, 2, 1 multiplied 6 over s4. Let's say one more, cos hyperbolic of 3t. Cos hyperbolic of kt is s over s square minus k square. Note that this s is not going to change when we put k. K is only going to replace here, not over here. So this s remains the same, whatever k is. So for example, cos hyperbolic 3t, s, no change, over s square, no change, minus 3 square, only k is going to be replaced with this 3 over here. This is our k. Right. So we get s over s square minus 9. Now you can click next to do the quiz.